Hello and welcome to the summary of roots of polynomial. The first topic in A is for the pure 1. In this topic, two big ideas are covered. The first one being the relationship between coefficient and roots. And this relationship is explored in equations of degree 2, 3 and 4. The second big idea is using a substitution to find another equation whose roots are related in a simple way. First, let's look at the relationship between coefficient and roots in a quadratic equation. As you can see here, this is a quadratic equation is given here, and the factors of the quadratic equation are z minus alpha, z minus beta, which means alpha and beta are the roots. Therefore, the sum of the roots, alpha plus beta, can be obtained by minus b by a, and the product of the roots, alpha beta, is c over a. Now let's extend this relationship to a cubic equation. We are given az cubed plus bz squared plus cz plus d is equal to 0. Which has factors z minus alpha, z minus beta and z minus gamma, meaning alpha, beta, gamma are the roots of this equation. The sum of the roots, alpha plus beta plus gamma, is equal to minus b by a, which comes from this coefficient and this coefficient. The sum of pairwise products, alpha beta plus beta gamma plus alpha gamma, is equal to c by a, which makes use of this coefficient. And the product of the root, alpha beta gamma, is equal to minus d by a, makes use of this coefficient. You can also see that as we start from the sum of the roots and work our way down, the negative sign keeps alternating. That is, the first one has a negative, this is a positive, and this is a negative as well. Now let's take an example and see how this relationship is applied. The question is, find a cubic equation whose roots are 4, 3 and minus 2. So we are asked to find an equation, the roots are given. So now we are going to make use of the relationships that we have seen earlier and try to find the equation. So we know that the sum of the roots is alpha plus beta plus gamma. So we add all the three roots together and then we get 5. Then we do the pairwise product. So that is alpha beta plus beta gamma plus gamma alpha is equal to negative 2. Then the product of the roots, alpha beta gamma, is equal to minus 24. So now we can write the equation. The equation that we are looking for is x cubed minus 5x squared minus 2x plus 24. If you remember, this is minus b by a, this is c by a, and this is minus d by a. So a is 1 and we need minus b, so therefore this is negative 5. Also same here, this is also negative, so this becomes positive 24, and c remains the same, so minus 2. So that's an equation right there. The second big idea in this topic is, if we know roots of one polynomial, we can find another polynomial whose roots are related to the original one. So in this table, you are given some common relationships that could be asked in a question. So the relationship between the new root and the original root is 2 times. So you got w is equal to 2 alpha, and therefore you can make the substitution alpha is equal to w by 2. The same thing, 3 alpha minus 1, then you make this substitution right here, and so on. Now let's take an example to see how we can use the relationship between roots to find the new equation. So in this question, we are asked to find an equation whose roots are alpha square, beta square, and gamma square. The original equation that is given to us is 3x cubed minus 7x squared plus 11x minus 5 is equal to 0, whose roots are given as alpha, beta, and gamma. So the first step that we need to do is we need to make a substitution. So the substitution we are choosing to make here is it will replace x by root y in the original equation, because the relationship between the original roots and the new roots are alpha and alpha square. So now in the given equation we've replaced x with root y throughout the equation, and then root y cubed can be split as root y square and root y, so hence you have that. And the negative values are moved to the right hand side, so this becomes 7y, and the negative 5 also moves to the right side, you get plus 5, and then this remains the same. Now we will square on both sides. When you square and expand, you get 3 terms on the left, 3 terms on the right. If you move all the terms on the right to the left and simplify, you will get the required equation, which is 9y cubed plus 17y squared plus 51y minus 25 is equal to 0. So now you can see how we are able to find a new equation by identifying the relationship between the roots of the two equations. The original equation's roots were alpha, beta, gamma. We've now found a new cubic equation whose roots are alpha square, beta square, and gamma square.